The reason we use moles in chemistry is that they provide a connection between the microscopic world, the world of molecules and atoms, and the large-scale everyday world, the laboratory world that is full of substances that we can weigh on a balance. And specifically what moles do is they connect masses with the number of molecules that you've got. So let's work on the other half of the relationship with moles. We've already seen how moles are connected with molecules. Let's connect mass and moles. And we can do it using what we've talked about with atomic mass units. Let's try to figure out if we have exactly 1 mole of iron. Let's figure out how many grams of iron that is. Alright, we're going to have to think back on what we know about mass and substances, and one of the things that we said was you could get the mass of a molecule or an atom of something by looking at the periodic table. If I look at the periodic table here, the atomic mass of iron is 55.85. And what that means is that I can write 55.85 U is the mass of 1 atom of iron. Now, that is a critical link here, because what I'm looking for is some kind of thing that's connected with particles, which moles are, and something that's connected with mass, which atomic mass units are. So I can drop these 2 units into my root map here. This is U of iron if I want to be picky, and this is atoms. And this is the link between U and atoms here. Now, I already have a link between atomic mass units and grams. We said that was where Avogadro's number came from. There are 6.022 times 10 to the 23rd U in 1 gram. So there are 2 ways that we use Avogadro's number. One is it's the number of atomic mass units in a gram, and the second thing is it's the number of molecules in a mole, right? So we're using the gram to atomic mass unit conversion there. Now, how about moles to atoms? Well, this is moles to particles, so again, it's going to be Avogadro's number. It said that there are 6.022 times 10 to the 23rd atoms of Fe in 1 mole of Fe. That's the definition of a mole. So now we've got Avogadro's number showing up twice here. Now watch what happens when we turn this into a problem. Start off with your 1 mole of iron. And now, what has to go down here? Well, I've got to cancel out moles of iron. There's 1 mole of iron for every 6.022 times 10 to the 23rd atoms of iron. Okay? And now, that will get rid of moles of iron. Now I've got atoms. I want to get rid of those. So they're going to go on the bottom of this next one. Here's my link here. The atoms had to go on the bottom to cancel this out, and now have U of iron on top. And now I've got atomic mass units that I want to get rid of, so that's going to have to go down here. And there are 6.022 times 10 to the 23rd atomic mass units in 1 gram of iron, or anything else. Now look what happens. It's going to be easier for me to type this into the calculator because there's Avogadro's number on the top and Avogadro's number on the bottom, so I never actually have to put that in. So 1 mole of iron equals 55.85 grams of iron. Now here is what I was after, the mass of 1 mole. 55.85 is the mass of 1 mole of iron. Now, I can simply look at the periodic table now, and I can say 55.85 U is the mass of an atom of iron, but 55.85 grams is the mass of 1 mole of iron. What's the mass of 1 mole of copper? 63.55 grams of copper is the mass of 1 mole of copper. What's the mass of nitrogen? 14.01 grams of nitrogen, N, is 1 mole of nitrogen. So I can get any place that I can write a conversion factor between atoms and atomic mass units. I can use that same number to write a conversion factor between grams and moles from the periodic table. How about water? Let's get the mass of 1 mole of water. It's going to be the same kind of thing. We're going to go from moles to molecules, just like we just did, to atomic mass units, to grams. So that is our roadmap for this. Let's look at it. Going from moles to molecules, I'm going to have to put the moles on the bottom. And there are 6.022 times 10 to the 23rd molecules of water on the top. Now that cancels that out. I've got molecules that I want to get rid of, so I know they have to go down here. And what do I know about molecules in U? Because that's what's going to go here. U is going to be on top. Well, we figured this out in the last frame. If you add up the masses of all of the stuff that is in water, we've got 2 hydrogens, and we've got 1 oxygen. And if we add the masses of those things up, we'll get the mass of a water molecule. On this table, hydrogen is 1.008. So 2 times 1.008 plus, on this table, oxygen is 16.00. And if we add those up, we're going to get 18.016, right? Okay, now what is that number? That can tell us how many U that we've got for a water molecule. And that's 1 molecule. And then we can go from U to grams. And again, I see that the Avogadro number cancels out, so I never really have to punch it in. And there's nothing left except 18.016. So 1 mole of water is 18.016 grams, and 1 molecule of water is 18.016 U. So you can use that number, 18.016, both ways. It can give you the mass of a molecule, can give you the mass of a mole. Now, we can use this as a conversion factor in further problems. let's repeat the raindrop problem that we had done at the beginning of this lesson. We had tried to figure out how many molecules there were in a drop of rain. Well, we said a drop of rain was 0.05 grams of water. Now I can figure out how many moles of water I've got from this and then convert moles into molecules. So I can use moles this time, and I don't have to bring atomic mass units into the calculation at all. So we already did this calculation with atomic mass units. Here we're doing it without atomic mass units. I can use this to take me to moles. And then I can use moles to take me to molecules. And I'm going to get the exact same result that I got in the other video using atomic mass units. And in fact, you can see that the numbers are pretty much the same, although there I think we rounded this one off a little bit more because we were using a table that didn't have as many significant digits on it. So 0.05 divided by 18.016 times 6.022 23 gives me 1.67 times 10 to the 21. Molecules. And of course my significant figures are off because there's only one significant figure here, so there should be one here. So I should really write this as 2 times 10 to the 21 molecules. Now what I want to show you here is that the molar mass is the same as the molecular mass. Here's the molecular mass, it's in U, and the molar mass is in grams. So it just depends on which unit you put there, whether you've got a molecular mass, the mass of a molecule, or a molar mass, the mass of a mole. That's point 1 that I really want you to know. And point 2 is that you can do unit conversions now with moles without dragging atomic mass units into them at all. We did an example here. Here's a pattern that you're going to see over and over again. You're going to be given grams of a material, and you want to convert it into molecules of a material. You have to go through moles. So here's moles. Sometimes you can remember things a little bit easier if you draw like kind of a dopey picture that goes with it. It sticks in your head better. Okay, so there's moles, that's in the center. You can go back and forth between grams and moles if you have the molar mass, and you know how to get the molar mass now, I hope. And you can go between moles and molecules if you have Avogadro's number. So this is a roadmap that you can use. Always, if you're trying to go from a mass to a number of molecules, you can drop moles in to connect those things.